Okay, good morning, students. In today's lecture, we are going to start a new topic that is your engineering materials, their classifications, their composition and properties. So, what are engineering materials? In broader sense, if we see that those materials that can be used for engineering and technological purposes. Okay. Um, if we look into the history part, and you can see that because if we are looking at the what is the importance of materials, so even if you go through the history, you will see that in history the various historical ages they were named after materials. Like we used to have Stone Age, Bronze Age was there, Iron Age, Steel Age was there. Then your Space Age came in. Okay, so if materials were not that important, then even the ages, the historical ages, would not have been named after the materials. Now, if you look at in your surroundings, okay, so if you're looking at, you are sitting in your house or in your college, the building is made up of a material, that is bricks are there, cement is there, uh, gravel is there, sand is there, steel is there. So the buildings, they are made up of different materials. Doors, they are either made of say wood or aluminum, so that they are also made up of different materials. If you look into your computer, your mobile, your table, chairs, beds, all the utensils you use at your home, okay, the water bottles, if you go outside your car, your truck, the bus, your all the aircrafts, ships. So everything around you that you use in your daily life is made up of some material. So that is why these materials are a very essential part of our daily life. Okay. So if we look into the classification of materials, so engineering materials can be classified as your metallic materials and non-metallic materials. So there can be metals and non-metals. So metallic materials can then again be subdivided into ferrous materials and non-ferrous materials. Ferrous materials are those which have iron in it. So Fe is the symbol for iron. So that is why if in a material iron is present, then such a material is known as ferrous material. And the materials that do not have iron in it, those are known as non-ferrous materials. In ferrous materials, again, they can be subdivided into your cast iron and steels. Steels can be again of your plain steel is there, carbon type steel is there, and your alloy steels are there. Cast iron can be again subdivided into say gray cast iron, white cast iron, malleable cast iron, ductile cast iron, or nodular cast iron. Okay, so these are your ferrous materials. And in non-ferrous materials, you can come up with materials like aluminium, copper, magnesium, tin is there, zinc, lead, then alloys, the different nickels and alloys are there, nickel and their alloys are there. So these are all your non-ferrous materials. In non-metallic materials, you can go for, there can be two types. There can be organic and inorganic materials. Organic materials are that are available in nature or that are produced by nature. Okay. And inorganic are that are man-made, okay, that are made by humans. They are known as inorganic materials. Now, organic materials can be, we have plastic, wood, paper, rubber, leather, petroleum. All these are organic materials. Inorganic materials can be your minerals, cement is there, glass, ceramics, graphite. So all these are inorganic in nature. Now, if we talk of metals and alloys, now metals and alloys can be again of divided into ferrous and non-ferrous. Okay, so ferrous materials can be subdivided into steels, and you have the cast iron is there. So cast iron can be gray iron, ductile or nodular iron is there, white iron, and malleable iron is there, depending upon the various say ingredients that we put in or different metals that we put in. So we can change or we can tailor made our material by making an alloy. Now, steel, on other hand, can be of low alloy and high alloy steel. Okay. So steels, if we talk of metals, metals are pure in its form. Okay. So there is no impurity in metals. Okay. But alloy, on the other hand, these are made by mixing, say, two or three metals in a homogeneous mixture. Yeah, so what we do is we melt two metals and then we mix them. Okay, so both the metals, they melt and they form bonds with each other. Okay, so and then the final product after cooling down is an alloy. Okay, so steels are made up of, they are actually alloys. Okay, so in this we have low alloy and high alloy steel. In low alloy steel, we can have you can say carbon steels. We have low carbon steel, medium carbon steel, and high carbon steel. Low carbon steel can be plain low carbon steel, or we can go for high strength and high strength low alloy carbon steel. Then medium carbon steel can be plain and heat treatable. High carbon steel can be plain and tool steel can be there. High alloy steels can come under the, they can be divided into two subcategories, that is tool steel and your stainless steel. Okay, so this is the classification of metal alloys. So this is the classification for ferrous alloys. Okay. Now, if we look into metals, metals are elements that or the substances they that are available in nature in its pure form. While alloys, we have already discussed, they are formed by mixing two or more metals in the form of a homogeneous mixture. So, examples of metal can be your iron, and alloy can be your steel. Now, classification of metals can be ferrous and non-ferrous. So ferrous metals, the word ferrous is derived from the Latin term that is ferrum, which means iron. So this means the metals which contain iron as its main element, maximum percentage is your iron. So such elements are such metals are known as ferrous metals. So ferrous metals, they possess high strength and they are relatively low in cost as compared to other materials that are available. Now they are used in applications where weight is not the primary influencing factor. So because the density of ferrous metals is high, so if we do not have this constraint of weight, so we can use ferrous metals. So the ferrous metals can be your pig iron is there, cast iron, wrought iron, and steel. All these are ferrous metals. So pig iron is the first stage when the ore, iron ore is taken out from the earth. Uh, so the first stage is of iron that is known as your pig iron, and this pig iron is produced from the blast furnace. Now this contains around 3.5 to 4.5% of carbon, along with you can have silicon and other constituents in lower percentage such as sulfur, manganese, and phosphorus that is mixed inside the pig iron. Now these contents, all these contents, because the carbon content is very high in it, it is 3.5 to 4.5%. Now this makes this pig iron very brittle, and we cannot directly use this metal for making different components. Okay. So pig iron is produced in blast furnace and it is poured in molds, and we prepare after this these billets or molds, they are used to prepare different say materials such as your wrought iron, cast iron, or steels. So pig iron is the first stage of iron extraction that is extracted inside the blast furnace. Then comes the second we can make is the wrought iron. Okay. Now wrought iron is made from the pig iron in a puddling furnace. The carbon content in this wrought iron is very less as compared to the pig iron. So here you can see that the chemical composition of wrought iron, so it has 99.8% of iron and only 0.02% of carbon is there, and 0.12% silicon, and small other constituents are there, that is sulfur, manganese, and phosphorus will be there. So this means this lower carbon content makes this wrought iron ductile. Okay, and this wrought iron is soft as compared to the pig iron. It becomes ductile because carbon content is less. Very high toughness. So wrought iron is very tough in its nature. And due to this low carbon content, the melting point is very high. So melting point, it increases. Now, if we compare the melting point of say pig iron melting point is around 1000 to 1200 degrees centigrade. Cast iron is having the same around 1100 to 1200 degrees centigrade. But on the other hand, wrought iron, if you look, because the carbon content is very less, the melting point of wrought iron, it reaches around 1500 degrees centigrade. So this decreasing the carbon content, it increases the melting point of the metal also. So wrought iron has a melting point of 1500 degree centigrade. If you look into the application point of view, because it is a highly corrosion resistance, so it is made, it is used in making your steam and water pipes. Also, it is used for making your engine bolts and the various railway couplings. So this is the application of wrought iron. After wrought iron, there is cast iron is there. Now